All right, advanced students. So we're doing the last lesson of logs that we need to know, and that's the difference between a regular log and a natural log, which is ln. And so let's talk about that, okay? Before we get into that, I'm going to introduce you to a new number. So you guys know and girls know pi. So pi is, I'm going to use the squiggly lines because pi is about 3.14, right? We did that a lot when it comes to like circles. Today we're going to learn a new number that's kind of like pi, but because pi is an approximation, it's not an exact number. Um, E is also a number that's like that, right? Right? It's a number that it kind of keeps on going, but E is about 2.72. E is about 2.72. All right, so magically there is a calculator that I opened up because I wanted to show you where E is on the calculator. Everything can be done right on the calculator. So if you look, there's the on button, there's a STO or store button, there's a LN button, and above that there's an E button. To get to that E button, you're going to hit second and the E, and let's just see what E is to the first power. So if I hit enter, right, you can see that E is a long number, kind of like pi. If I were to do the same thing with pi, which is over here, you'll see that both numbers keep on going, right? It's a long number, there's no pattern to it. This is called irrational, okay? So E is about 2.72. That's all you need to know for the purposes of this assignment for right now, okay? Um, there is, we talked about log. We talked about if there is no base, there's automatically a base of 10. But there's a very specific name for log with a base of e of a number, right? So log base e is the same thing called an ln or a natural log, which in the calculator, that's what this ln stands for. It's a natural log. So if let me just show you something real quick. If I do ln of e, um, and I plug that into the calculator, there's where E is as well. ln of E is 1, okay? So we'll go into a couple of examples so that way you could see what this exactly means. Let me just show you one other thing real quick before I move on, okay? Let's just say I had a number, like 10 is equal to e to the x power, and I want to find out. So remember, the only variable here is x, right? Because e is a number. It's like almost 3. So I want to find out what this exponent is. So what you can do, and the reason why I taught you the e's and the ln is because e and ln are opposites of each other. E and ln are opposites of each other. They are opposites. They undo each other. Addition undoes subtraction, multiplication undoes division, e and ln undo each other. Okay, so what do I mean by that? To get rid of this e, what you do is you do the ln of both sides. So e to the x is equal, so if I ln the right, I have to also ln the left, or natural log. Um, and ln of 10 is a number, so I could just leave that as ln of 10 is equal to ln and e. Again, what do? They cancel each other out. So ln and e cancel each other out, and you're just left with x. So x equals the ln of 10. All right, so let's do a couple of problems to make sure that this kind of sinks in. This is always a lesson that people usually have trouble with, but we'll practice this together just to make sure. Okay, so we have an equation. We're going to take this slow, okay? We have an equation. So P equals 500 e to the 0.035 t. That's the same thing as 0.035 t. And they're telling us, it says how many llamas were introduced at t equals 0. So if I were to go ahead and replace the number 0 here, I'd have equals 500 e to the 0.035 times 0. Anything times 0 is 0. So this is the same thing as 500 times e to the 0 power. So I'm going to put that into the calculator. So I hit the calculator. Let me go ahead and just clear what's there. So I'm going to type 500 And I'm only doing this to show you how to plug things into the calculator. 500, 100, come on. E to the, which is right there. So I'm going to hit second ln, and I have 0 power. Okay, so there are two e's in the calculator. I think you saw me do one before. So this is e to the x power, and over here above the division is just a regular e. You could have used either one. So boom, that's 500. So the answer to part A, is equal to 500. So 500 llamas. This is how many were initially introduced at t equals 0. Okay. For part B, it says approximately or algebraically determine the number of years for the population to reach 600. So we want this P to be 600. So we're going to go 600 equals 500 e to the 0.035t. We have to get the weird thing. I call it the weird thing, which is all of this right here. We have to get this by itself. So we do that. 500 and e are being held together by multiplication. So to undo multiplication, I want to divide. So divide both sides by 500. The 500s cancel out on the right hand side. So I'm left with e to the 0.035t. 600 divided by 500 is, let's go ahead and use the calculator for that. I said calculator. Here we go. All right, so I'm going to do 600 divided by 500. Enter. Then I get 1.2. So I have 1.2. And just like we did on the previous slide, right, the opposite of E is ln. So we're going to ln both. So ln of 1.2 is equal to ln of e to the 0.035t. ln and e cancel each other out. So I'm left with ln of 1.2 equals 0.035t. You can put a 0 here if you'd like. To get the t by itself, this is multiplication, so we have to divide both sides by 0.035 divided by 0.035. And then it says round our answer to the nearest tenth of a year. So now this is all calculator work, right? So the ln is right here, so I'm going to put that. In the parentheses, I'm going to put 1.2. I'm going to close that parentheses. I'm going to do the division symbol. Or you could have alpha y equals option 1, which is a fraction. On the bottom, I have 0.035 or 0.035, same thing. And I have 5.209, so I have to take this and round it to the nearest tenth. The tenth is the second number. I look at the number to the right, that's not 5 or above, so this is about. So t is about 5.2. And that's the answer to this question. Okay. We'll go ahead and do this question right here. So like I told you in the previous example, we want to get the weird thing by itself. So this right here to me is the weird thing, right? I'm going to get that by itself. So we have 3 times this weird thing. Minus 17 equals negative 5. So first thing we're going to do is get rid of this minus 17. You know this from Algebra 1. So I have 3. That whole weird thing, ln of 4x minus 5, this cancels out, equals 17 minus 5 is 12, which works out nicely because to get rid of that 3, I divide both sides by 3. This cancels out, so I'm going to take it over here. So I have ln of 4x minus 5 equals 4. To get rid of the ln, so e and ln undo each other, so watch where I'm going to put it, okay? I'm not just going to put it anywhere. I'm going to put the e as the base. I'm going to put the e as the base, right? So the e and the ln right now, they're going to cancel each other out. So I have 4x minus 5 equals e to the 4th. And now I'm just going to do the regular thing like in Algebra 1, right? I'm going to add 5 because I got to get the, I said add 5 because I got to get the x by itself. So add 5. Add 5. So this is e to the 4th plus 5. Not the same thing as e to the 9th. This cancels out, so I have 4x equals e to the 4th plus 5. And then to get the 4 away from the x, I'm going to divide both sides by 4. So this cancels out, and I get x equals e to the fourth plus 5 over 4. I'm just going to go, so I got my x by itself, okay? So this just becomes a calculator question. I'm going to go up here, and it says solve for the exact value of x. Since it says exact, I'm done. I'm going to take all of this, plug it into Delta Math, and that is my answer, right? Let me know if you need help. This is not an easy topic.